Alright class, so since the weather wasn't looking good, decided to go ahead and cancel class just because I thought many of you might not come anyway, and I wanted to make sure that we were all sort of on the same page when we got to class together on Wednesday. Because we also note you actually have a quiz on Wednesday over this material as well. So you would already hopefully watch the two videos that the video that you needed for class today. So what we're going to start with is technically a review of what that video was. So our first thing we're going to do is an example, and this time we're looking at house values in a certain town. It tells us that it's relatively normal with a mean of $156,000. So this is going to be our mu that we have, and a standard deviation of $23,600. So that's going to be our standard deviation, or our sigma. Our first question asks us to find the probability that a randomly selected house in this town has a value that is less than $190,000. Now note, before I even do this example, since you already had the practice in the last video, you could always pause the video here and try to work the problem first yourself and then see how you did. But what we're going to start with here first then is our picture. And just as with before, I'm going to put the mean on there, and I'm going to go out my increments of the standard deviation. So I'm going to start that my mean is $156,000. My standard deviation is $23,600. So as I go to the left here, I'm going to subtract that $23,600 and get the $132,400. Subtract that $23,600 again and get $108,800, and finally subtract the $23,600 again to get our $85,200. And again, the other direction, we're just going to add the $23,600 to our $156,000 there. So we're going to get $179,600. Add the $23,600 again, and we're going to get $203,200. And finally, one more time, add that $23,600 to get the $22,600. So that's just coming from your mean and standard deviation. Then now the problem asks us to find the probability that it is less than $190,000. So I'm going to find about where $190,000 is on my picture. Right, it's somewhere here between that 179 and 203. And so that is our $190,000. It says less than that value, so because of the less than, we're going to shade to the left. Right, our next step is to find our z. Remember, the formula for z is y minus mu over sigma. So our y is the 190,000. The mean is 156,000. And the standard deviation is $23,600, which gives me a z of 1.44. Now remember, these I'm going to round to 2 decimals just because that's what our table has, is 2 decimals. Right, so that's actually the next thing that we're doing. We're going to pull up our table and we're going to look up that z of 1.44. So here's the negative side of the z table, going to the positive side here. Going to that 1.4 row and that 0.04 column, and finding where that lines up gets me this 0.9251. Now the next question is this number I found what I want? So remember, what I like about this table is it does have this little picture here at the top that it shades to the left. Which way was our picture shaded? Well, our picture was also shaded to the left, so this is actually our answer. So our probability is just going to be the 0.9251. Right, and then the last thing we just have to do then is interpret this number. So I can say the probability that a randomly selected house in this town has a value that is less than our $190,000 is, and I can either leave the decimal form of the 0.9251 or change it to a percentage of 92.51%. Again, one thing that's great about drawing the picture is I can already see two different things from this picture. One, I can see my picture is shaded left and my table is shaded left, so I already know I don't have to use any of my rules that I learned on this one. I can also tell you that my answer is going to be bigger than 50%. So if I had everything just to the left of this 156,000 shaded, would be 50%, so I have more because I have this piece over here as well. Alright, so let's look at doing another example. And again, you can always pause it, work the problem on your own, and see if we agree or not. So this time I'm going to start with the same picture because I haven't changed what I'm working with. It's still the house prices, and it's still going to have the same numbers along the bottom because I haven't changed the mean and I haven't changed the standard deviation at all. So let me just add all of those numbers along the bottom here real quick. And the 226. Alright, now this question asks us to find the probability that the value is more than 140,000. So looking for where 140,000 is, right, it's between the 132 and the 156,000, technically a little bit closer to this 132,000. So about right there is my 140,000. Then it's going to figure out if I'm going to shade to the left or shade to the right. So it tells me more than, so I'm going to shade to the right. We're going to find our Z. But again, before we actually find our Z, sometimes it's good just to use this picture. So two things I already should know. Am I going to have to use a rule on this one? Well, my answer should be yes, because it's shaded to the right, my table is shaded left. That tells me I'm going to need to use my 1 minus rule on this one. Secondly, again, I can tell you my answer is going to be bigger than 50%, because my mean is at 156,000, so if I got everything just to the right of that shaded, that would be 50%. I definitely have more than that shaded here. So now finding our Z, same formula. It's a different value for Y this time. So this time our value of Y is 140,000, but our mean is still 156,000. The standard deviation is still 23,600. Rounding our Z to 2 decimal points, I'm going to get a negative 0.68. And again, from my picture, that should also make sense, right? Because I'm not quite 1 standard deviation below the mean. So I'm less than 1 standard deviation below, so it's negative since I'm below the mean, and tells you how many standard deviations below we are. We're going to take that number and we're going to go to the table to see what number we get. So negative 0.68 this time. So I'm going to go to the negative side. First, here's my negative 0.6 row. My 8 column is the second to last one that I can see there. if my auto scroll would stop. I'm going to find this 0.2483. Now again, is that the number I actually want? That tells me what's to the left of my number. So if I go to my picture, this 0.2483 is technically this piece of my picture. So that's not the piece I want. That's technically the opposite of the piece I want. So since we wanted shaded right, we're going to do our 1 minus rule. So we're going to take the 1 minus the 0.2483 and get a 0.7517, which is now also bigger than our 50% that we knew our answer should be. Finally interpreting it, so we can say the probability that a randomly selected house in this town has a value that is more than 140,000 is our 0.7517 or 75.17%. Alright, so our last example of these. We want to find the probability that a randomly selected house has a value between the 135,000 and 185,000. So I'm going to start again with that same picture because the mean and standard deviation are exactly the same. And this time it's asked for the 135,000 and 185,000. So 135,000 is about right here. And our 185,000 is right about there. I can't apparently draw on my line here very well. There we go. And so we're going to shade everything between those two. Alright, so with this one, only a couple of different things I can tell you. So I can tell you that I need to use the between rule. Right, I don't have everything to the left shaded. I don't have everything to the right shaded, so it's neither one of those things. And the only other thing I can really tell you is what kind of values my z will be. So I can tell you right now that one of my z's will be negative, one of my z's will be positive. I can also tell you about where they're going to be. This one's going to be between 0 and -1. This one's going to be between 1 and 2. So that's our next thing we want to do, is actually calculate our z's. And generally when I do the between rule, I do the larger one first. It doesn't matter which one you do first though. So we're going to do 185,000 minus 156,000 over our 23,600, which gives us a z of positive 1.23, right? I knew it should be between positive 1 and positive 2 from my picture. I'm going to do the same thing with my other values, this time the 135,000. Over our 23,600 will give us a z of negative 0.89. So again, negative since we're below the mean. We're not quite one standard deviation below. I'm going to take each of those numbers now to my table. So let's look up the positive 1.23. So here's the 1.2 part, the 3 as our column, giving me 0.8907 for that number. And we'll do the same thing, go into our table with our negative 0.89. So notice 9 is our last column there. So the negative 0.89 gives us the 0.1867. So there's our values from our table. Now we just got to decide what we're going to do with those, right? Because we only want one probability. So the between rule tells us that we're going to take our two numbers we just found from the table and we're going to subtract them. It's always going to be the larger one minus the smaller one because probabilities have to be positive. So this is going to be 0.8907 minus 0.1867, giving us 0.7040. And then finally, interpreting it. So we can say the probability that a randomly selected house in this town has a value between our $135,000 and $185,000 is our 0.7040, or what is 70.40%. So that's some good practice of what we were doing in the last video. And hopefully those make sense. So you got to see another example of one that was shaded left, another example of one that was shaded right, and another example of where it was shaded between. So now that does probably make good sense. We're going to change things around on you a little bit. So as it says here, suppose now instead of being interested in finding the probability of a certain value, we wanted to find a particular value that produced a certain probability. That is, we want to find a certain percentile. So first, let's sort of make sure I can kind of explain what I mean without even just looking at this first example. So for example, when my children go for their doctor's visits, I'm told quite often what percentile they're at. So I might come back one day and say, well, my son was at the 95th percentile for height. I want you to tell me how tall is he. So we're going to start by looking at an example, looking back at women's heights. If you remember, women's heights was normally distributed with a mean of 65 and a standard deviation of 2.75. So I'm going to go ahead and start by just drawing the picture that we already know is true, right? So we know it's normal. We know the mean is 65. And this time my increment's going to be 2.75, so I'm just going to subtract 2.75 as I go to the left here each time. And then add it when I go to the right. But this time it says I want to find what height cuts off the bottom 10% of women's heights. Alright, so what I would know is, okay, bottom sort of tells me that I want this side, and I want to find the bottom 10%. Well, and for the most part, for a lot of you, at this point, you don't have to put these extra numbers at the bottom. You can just put the 65 if you want, because it's a little bit harder for students at this point to sort of ballpark where that number should be. I've just been doing this a little bit longer. So here's what I know. Right, what I know is that there's 68% between the 62.25 and 67.75, which means there's 16% below here and 16% above here. So I know it's going to be somewhere a little bit further than that 62.25 below it. But again, you might not technically know that. So what I want is for this to be 10%, and what I want is to find this number along the bottom. So that's our goal. So as you can see from the picture, it's different. Before we knew the number along the bottom and we were trying to find the shaded area. This time we know the shaded area and we're trying to find the number along the bottom. So we're going to start by looking at our Z formula that we already have and figure out what information that we already know or could find. Well, things I know, right? I already know the mean and I already know the standard deviation, right? Those are things I know. To understand what information we could find with a little work, let's actually first talk about what our goal is. So if I look at my picture, my goal is to find a woman's height. Which of these letters represents a woman's height? That's our Y. So my goal is to find Y. So I don't know that, which tells me then what I need to know is Z. If I know Z and I know sigma and I know mu, I can find my value of Y. So what we're going to do is we take this formula and we're just going to solve it for Y. So Y is going to be Z times our standard deviation plus our mean. So we're actually going to go back and finish the problem that I started. We're going to kind of go through the little directions that I have here. So the first part of the direction is to graph the curve with the mean plotted. I already did that. I determined how much was shaded, 10%, and where it should go relative to the mean, so I know that my value is going to be below the mean. We're going to decide how much area is to the left of that value. So let's go to that part. So looking at my picture here, right, so I know my value is less than the mean. That's the bottom 10%, and there's 50% below 65, so the bottom 10% is somewhere to the left of the mean. That much I know. I want this to be 10%. So where I'm going to go to find my Z is going to be our table that we're used to, right? Z is in here. Z is the row in the column. So this time my goal is actually to start with a number here in the middle and work out to find the Z. Now if I remember, my picture is shaded to the left. So that's why when I go to my picture, I'm looking for to the left. So I'm going to go to my question mark. How much is to the left of my question mark? 10%. So that's what I'm going to go looking for. Now we might not find this number exactly, but I'm going to add 4 decimals to it mainly because our table has 4 decimals for those numbers on the inside. I'm trying to find the closest thing I can to my 0.1000. Now as I go to my Z table, there's 2 sides to it. One is a negative side for the Z and one is a positive side for the Z. So what would be good for me to know is, do I already know which side of the table I should be looking at? And my answer is yes. Right? I know that I'm going to be below the mean, which tells me that my Z is going to be negative. So how I do this is I go down this first column looking for my jump of where 0.100 is happening. So if I kind of go down, I have this 0.0968 and 0.1151, and my 0.1000 is somewhere between those 2 numbers. I then am going to kind of look in both of these columns as I move over until I find the closest thing to 0.1000 that I can. So it's about the closest thing I find here is this 0.1003. So I'm just going to make a little note of that for myself here real quick. Now that's not my Z, that's just the number I found in my table. But now that I have that number, I can work out to find my Z. I'm going to ask myself, well, what row is that number in? -1.2. What column is that number in? Which is the 0.08. And I'm going to put those 2 numbers together to get me a Z of -1.28. Once I have that number, I'm just plugging that into my formula that I have here. So really, the work on these questions is in finding your z, because now if I know that y is z times sigma plus mu, I already know my z now, I already know mu, and I already know sigma. So at this point, it's really just plugging those numbers in. And then doing the math here, we get 61.48. Now what kind of units is that? We're actually finding women's height, so that's actually in inches. So what this number actually means, right, our last thing is interpretation. So 10% of women are shorter than 61.48 inches. All right, so as you can see from this example, the main work here is in finding the z, so we're going to do a few more, of course, to practice this as well. So we're still going to work with women's heights, and this time we're going to find the value that cuts off the 25th percentile. So remember, percentile tells you how much is to the left or below that number. So if I think about it, 65 is actually my 50th percentile because 50% is below it. So the 25th percentile has to be somewhere below 65. So that much I know. So I want this to be 25%. Again, my goal is to find that height. So I already know that my z should be negative because I'm going to be below 65, knowing that from my picture. So I already know which side of the table I'm going to be going to as well. So I go to my question mark. How much is to the left of my question mark? Well, that's just that 25%. So I'm going to go to the table looking for our 0.2500. And again, I know my z is going to be negative, so I know which side of my table to be looking at. So I'm still going to go down this first column here and look for where I see 0.25 happening. So I go 0.21, 0.24, 0.27, so 0.25 is somewhere between those two numbers. Work until I find the closest thing I can. I don't find something near as close. I see a 0.2514, and I see a 0.2483, and my 0.2500 is somewhere between those two numbers. If you pick either of these numbers, I'm going to be happy with you. This one's a tiny bit closer to 0.2500, so that's why I'm going to pick that one. So I'm going to say then that I found 0.2514. And again, that's not what I actually need yet. That's going to help me tell me what my z actually is. So now I figure out what row I'm in, which is negative 0.6, which column I'm in. So I have to scroll up here. I'm in the 7 column. So my z then is going to be negative 0.67. Once I have that, I'm just plugging that in to my formula here. So my z is negative 0.67. My standard deviation was 2.75. And my mean was 65. So this time my y is going to be 63.16 inches. That makes sense for my picture as well, right? It's below 65. That's also about a little bit more than 5'3", which is a reasonable height for a woman as well. So then this time I can say that 25% of women are 63.16 inches or shorter. All right. Another example. We want to find the height that cuts off the top 25% of women's heights. So just as before, I'm going to start with my picture. My mean is still 65, but this time it says top 25%. So top makes me think right-hand side. So 65 would be the top 50%, right? Because 50% is above 65. So the top 25% would have to be shifted over above that sum. So this time we want this to be 25%. Our goal to find that number. Now the next step tells me to go to my question mark and ask myself how much is to the left of that question mark. Well, there's 25% to the right of it, so how much is actually to the left of it? Right, so there's actually got to be 75% there, so that's actually the number I'm going to go to the table looking for. And again, why? My table always reads left, so whenever I go there, I have to be looking left. And again, this time I actually know for my picture, my z is going to be positive because I'm above the mean as well. So I'm going to go to my table, I'm going to go to the positive side here. Still going down this first column, looking for my jump. So there's 0.7257, 0.7580. So my 0.7500 is between those. Work over to the closest thing I got. Again, I find two that are somewhat close. 0.7486 and this 0.7517. Again, you pick either. I'm happy. Tiny bit closer is our 0.7486. So I'm going to write that down as what I have found. But then I need to actually know what my z is. So what row and what column does that number happen at? Well, it happens at positive 0.67. And this shouldn't be too surprising when you compare it to the last example. Here our z is a positive 0.67. Our z in our last example was a negative 0.67. So why is that happening? Well, here I had 25% on the left. Now I have 25% on the right. We're symmetric, so we're going to go the same number of standard deviations away, just in the opposite direction. So our y again is just z times sigma plus mu. So our z this time is positive 0.67. Standard deviation is still 2.75. Mean is still 65. So our y turns out to be 66.84 inches, which is bigger than 65, which makes sense for my picture. It's a little shy of 5'7". So again, a somewhat reasonable height for women. So this time, how would I interpret it? So I could say that 25% of women are, well, this time we shaded right, so I'm going to say are taller than our 0.84 inches. Right, one more example of these to start. So what value separates the middle 75%? So a little bit different. So my mean is still 65. So this time I want middle. So I want this. I want it to be 75%. So this time I'm actually finding two numbers along the bottom. Here's things I know. One's going to be smaller than 65, one's going to be bigger than 65. I can also compare this a little bit to my normal curve rule. Right, so we know 68% is within one standard deviation. I want 75%, so I'm going to be a little bit more than one standard deviation away in either direction. But I'm going to first give this, I'm going to call this one question mark A, and this one question mark B, because we're just going to treat them as two separate problems. So the first thing I actually have to do is complete my picture. So I have 75% in the middle here. So how much do I have left to add to my picture? Right, I have 25% left to add. 2 different spots to put it in. So I'm going to have to divide by that by 2. So I'm going to put 12.5% on either side. So 12.5% in decimal is going to be 0.125, and I can double check that my picture still adds up to 100% here. Now, why did I do that? I had to figure out how much was to the left of my question mark here, so I needed to figure out that number. So first, for question mark A, we're going to go to the table. Now, looking for then that 0.1250. This one I can tell you my z should be negative as well. So going to the negative side, going to go down that first column, looking for my jump of 0.12 here. So 0.125 is somewhere between my 0.115 and 0.135. Find the closest thing I can. I find a 0.1251. Now I need to figure out what that z actually is. So what row is that at? Negative 1.1. What column is that at? The 5. So my z is going to be negative 1.15 for question mark A. So then we can plug that into our formula here. So negative 1.15 times our standard deviation plus our mean. So that one is going to turn out to be 61.84 inches for question mark A. Now we need to do question mark B. So looking at it, how much is to the left of it? Well, I have the 0.75 plus that 0.125 piece, so I need to add those two numbers together. So that should give me 0.875. I also know my z is going to be positive from my picture. So let's go to the table looking for 0.875. So other side here. Going down this first column looking for my jump. So between 0.864 and 0.885 is my 0.875. Find the closest thing I can. I find this 0.8749. So again, I just usually make a note of the number I found. Now we're going to work out to find our z. So our z this time is positive 1.15. And look, again, not a coincidence. This one was negative 1.15. This one's a positive 1.15 because I am symmetric here as well. So using our same formula, just a different z. This time our z is the positive 1.15. So this gives me my value of y to be 68.16 inches. So then finally I can say that 75% of women are between 61.84 inches, roughly 5'2", and 68.16 inches, which is roughly 5'8". Now, to truly make sure we're actually understanding what percentiles are, that's why I'm asking. We're going to look at the one that we just completed and understand what percentile is. So the two different numbers we found, so we found 61.84 inches, and we found 68.16 inches. And I want to figure out what percentile each of those are. So when I find a percentile, so what percent of women are shorter than 61.84 inches? Well, that's actually that 0.125. So this is actually the 12.5th percentile, because that's how much is below it or to the left of it. And if I look at this one, how much is to the left of it or below it is the 0.875. So this is the 87.5th percentile. So what you'll actually notice is the number that you find that you're going to look for in the table is actually the percentile of the number you're looking for, because that's how much is below it. Alright, so that is the material that we were going to cover in class today. So what you'll notice then is technically you still have another video or two here to watch. These videos are to help prepare you for your quiz. You get some more examples with working backwards, like we just got done doing. And then you have a big example where it sort of ties everything together and is recognizing when to do which type of thing there. Then when we get together on Wednesday, we have another example where I don't have the questions actually already fixed. I'm going to do things based upon what types of questions are asked of me. Okay, so that's where we're going to leave off. So make sure you're ready for day 4 when we get together on Wednesday. So make sure you're watching this video as well as the other videos to get you ready for Wednesday's class.